everyone, welcome to week 2 of pre-calculus. Make sure before we get started in the video that you've looked over the weekly calendar and you've got all your materials ready to take notes today on simplifying rational expressions. So with this video, we're going to look at 4 different examples. If you already know how to do the example we're going over, feel free to skip ahead, pause, jump around. That's one of the nice things that you can do with these types of lessons. So we're going to go through them one problem at a time. Feel free to jump around, pause, and everything as you see fit. If you're confused by anything, grab an appointment slot. They're not going to be mandatory this week. There's a couple of you who missed from last week who I'm going to ask you to join on. The rest of you, it's just going to be a nice tutoring option. So, rational expressions mean that it can be written as a fraction. Just like a rational number is a number that can be written as a fraction. Now, you're mostly going to be asked to simplify here, and when you're looking at a problem like this, the first thing you want to do if you're stuck is remember to factor, which we reviewed on the first week. So here, we're going to factor x squared plus 5x plus 6. We're looking for things that that multiply to 6 and add to 5. And that would be 2 and 3, since we're looking at all positive terms. So the numerator factors as x plus 3 times x plus 2. And the denominator factors as x plus 2 times x minus 2. Right, they multiply to -4 and they add to 0, since there's no center term. Now, once we have it factored, remember you can only simplify fractions by dividing away the same thing. You can't factor with addition. So now that they're in multiplication form, we can factor out an x plus 2 from the numerator and denominator, and we're left with a numerator of just x plus 3 over x minus 2. And since we can't cancel out these x's, they're being added and subtracted, we are going to leave it like that. So this is when it's just a single fraction. Sometimes we're adding and subtracting. When we add and subtract fractions, we need a common denominator. It's the same thing here. So again, the first thing we'll do is factor. And here we have x over x plus 3, because the first one doesn't factor, minus 3 over x plus 3 times x minus 3. And to get a common denominator, you'll notice both of these denominators have an x plus 3, but this other side is missing our x minus 3. So we can just multiply this first fraction by x minus 3 on both sides, and now we'll end up with the common denominator of x plus 3 times x minus 3. And our numerator here, we can distribute and then make sure that we're subtracting the 3, and our numerator is x squared minus 3x minus 3. This is not factorable, so I'm just going to erase this line a little bit short because I overdrew it. This numerator isn't factorable. There's nothing that multiplies and adds to -3. So then my final answer is x squared minus 3x minus 3 over, and just going to multiply these back together again, x squared minus 9 for our final answer there. Nice single fraction. So using this common denominator strategy is really helpful whenever you see an addition or subtraction sign in a fraction problem. That's just as true here. It's a fractions inside of fractions. It's a weird looking problem, but we see addition and subtraction. So we're going to do the same thing. We're going to think about a common denominator. So when we look at the common denominator, in this case, we see 2 denominators, one y, one x. So the common denominator would be x times y. And what we're going to do with that is we're going to multiply both sides of the fraction using that common denominator. So multiply by xy. As long as we're multiplying by the same thing, the fraction is going to stay equal, just like we would if it was numbers. And what I'm going to do when I distribute this to our addition problem in the numerator and our subtraction problem in the denominator is you'll see the math is about to become a little bit easier. So when I multiply that first fraction, I get x squared y over y plus xy all over xy, because we're multiplying that 1, minus y times xy all over x. And the nice thing that happens here is that in our two fractions inside of fractions, we can cancel out those terms, which means that we're ending up with just single fraction x squared minus xy over xy minus y times y, which I'll write as y squared. So there's no term alike between all four of these terms: x squared, xy, xy, y squared. That's not going to simplify any farther, and we can just leave it like that. If you're interested in an alternative method, there's one in the notes in the PDF. Our final answer we have here, 1 minus w squared over w cubed minus 1. This, it's really helpful to remember two things. The first one is from last week, where we said that anything to the n power minus 1 factors to w minus 1 times w to the n minus 1 plus all the way down to just 1. If you want to review that, you absolutely can. And so that helps us factor our denominator and numerator a little bit more easily. Our denominator then would be w minus 1, and then just count down w squared plus w plus 1. The numerator, 1 minus w, is going to be similar. We're just going to have the order switched around. So then it's 1 minus w times 1 plus w. Now, the next thing you're going to want to remember is you're looking here and you're like, well, none of these are exactly the same, but these two are really similar. It's just the order's different. And you absolutely can work with that. If we have something like a minus b over b minus a, that can simplify, but not to 1 with just regular crossing out, but to negative 1, because the subtraction's in the opposite order. So what's going to happen here is that when these cancel out, 1 minus w over w minus 1, it's going to create a negative, which you can write out just in front of the fraction if you like. So in our final answer, it's negative 1 plus w, or w plus 1, addition order doesn't matter, over w squared plus w plus 1. And that would be our final answer. Let me know if you have any questions about this or anything else in the comments, or you can jump on, grab any of the available tutoring appointments for the remainder of the week. Talk to you later. Bye.